Okay, can? Okay. Right, so without further ado, let's start the lesson. Right, so I believe this was the last slide that I ended off last week. Right, can you choose your particular solution to be very complicated form? Right, okay, so I mentioned that the method is self-correcting. Right, a false choice for YP or one with two field terms is the most serious. Right, you solve already, you won't be able to fully solve entirely, and then you can't get anything, right? But you give a more complicated one with too many terms, okay, it will still give you a correct answer, just that when you're solving, you have a lot of A, B, all the coefficient, a lot of zero, right? You kill off all the terms, right? Okay, but it will waste you a lot of time because this type of question is doing second derivative, and product rule with second derivative is troublesome, okay? Right, so this is the quick revision. Alright, this is the second order that we are dealing with today, right? Since last week, okay, the equation number 1. Okay, so it has an associated homogeneous DE where the right hand side we assume is 0 first. Alright, then based on the theory we have built up, the general solution, okay, the general solution for your number 1, right, where your f is not 0, it will be made up of a particular solution that leads to number 1, alright, as well as the general solution, as well as the complementary function. Okay, this is the complementary function, alright. Okay. Okay, let me remove all this. I think it's a little bit confusing. Yeah, let me remove all this. Okay, sorry. Wait, let me see. Okay, I think let's just focus on this part here. Yeah, let's just focus on this. Okay, right. So you will have the particular solution plus the complementary solution. Alright, okay, so this is the particular solution. Alright, particular solution to number 1. Alright, and then this is the complementary solution. Alright, complementary solution. Right, where we try to solve number 2. Okay, we try to solve number 2. Okay, so this is a quick summary page. Alright, I better not write all those things confusing. Okay, it's just your YP plus your YP plus your YC. Alright, that is the main theory. Okay, and then fx, okay, it can be of this form, right? Exponential, okay, or polynomial, or trigonometry, or I can even twist the question, product of 1, 2, 3, or sum of 1, 2, 3, or 4. Okay, I can mix and match. I can make it more complicated looking. Alright, okay. But with the theory that we have built up, you can solve everything. Okay, with the theory we have built up. Alright. Okay, so the theory we have built up is here. Alright, here. This is the one. Okay. Okay, if a term, right, I think this is the key one. This is the key one that I think a lot of people, right, maybe. Okay, if a term in your choice for YP happen to be a solution of the homogeneous ODE, alright, okay, multiply this usual trial YP by x or x squared. Right, if multiply x, there's still overlap, you multiply by x squared. Okay, throughout. Okay, throughout. Alright, throughout. Okay, so alright, so if a term okay, any term okay, if a term in your choice for YP, if any term inside there, alright, okay, 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 alright. So today I'm going to focus on these 3 questions here. Okay, today I'm going to focus on these 3 questions. Right, these are the type of questions, right, that are good for exam. Alright? Okay? These are the good questions that are good for exam. Alright? Because they are very involved, right, and they really test whether you understood the homogeneous and non-homogeneous. Alright? So make sure you can solve these three. Make sure you can solve these three questions. Alright? Okay? It's a very good illustration of the concept. Alright? Okay. Let's start the ball rolling. Alright? Let's start the ball rolling. So for this number 1, okay, let me copy out the question first. Right? Okay. Okay, let me put it here for you. Alright? Okay, your first step. Okay, your first step is, of course, right, to solve. Okay, for the homogeneous case. Alright, I will write out everything slowly, carefully, so that you can also go through my thinking process and also work out mentally together with me. Alright? Okay, so we first, okay, solve y prime prime plus 5y prime, alright, equal to 0. So, we learned previously that, okay, you turn this to r squared plus 5r equal to 0. So, r plus 5 equal to 0. This means that your r equal to 0 or r equal to minus 5. So straight away, then your y complementary function solution is C1 E0 times x plus C2 E negative 5x. Alright, and of course this is C1 plus C2 E negative 5x. Okay, this is your complementary solution. Let me highlight it. It's so important. This is so important. Okay, let's highlight it. Okay, this is important. Alright, and then we next look for a particular solution. Alright, we next look for a particular solution. Okay, so as I tell you already, the whole idea is guess and check, guess and check. Alright, so you guess. Okay, you have here is 4x squared. Okay, so you guess your y, particular ypx, equal to ax squared plus bx plus c. Okay, it must always be a full polynomial. Okay, alright, so even though your question is only 4x squared, you don't go and put ax squared. Cannot, right? You cannot just put ax squared. You have to put everything below. You have to put him, right, ax squared, and everything below him in terms of power, right? Because he may be available, but because of your y prime, well, y prime prime, so that means he may have contribution as well, right? So although he doesn't show up on the right hand side, doesn't mean that he is not there, right? It could be that because of y prime, he disappear. It's embedded inside lah, basically, or something plus something or something minus something. So they don't end up in the right hand side, but they are still important, right? They still have contribution, right? So it must be a full polynomial. Let's also highlight this guy together. Okay, this one is also important. Now, remember the very first thing I told you just now over here? Okay, where? Okay, here, right? This is so important that let me bring him to the, okay, so that we don't have to keep going back. Okay, let's put him here. Okay, let's put him here. Okay, let's put him here. Right? Okay, so you can see that if a term, or basically is any term in your choice for YP, happen to be a solution, right, of the homogeneous ODE, right, multiply the YP throughout by X. Okay? Alright? So, let's see, let's observe, let's observe. Okay? Let's observe. Observe that in your YP, the term C is a solution, right, to the homogeneous DE. Y prime prime plus 5y prime equal to 0. Okay? Alright? Let me make it more explicit for you. Okay? This plus C, right? This plus C, it overlap with your C here. Okay? So, okay, so we have to modify it as ypx equal to, you copy down the whole thing, ax squared plus bx plus c, your original guess, alright, you multiply by x throughout, right? So therefore, you will have ax cubed plus bx squared plus cx. And then you look back at your yc. Is there any more overlapping? No more. Okay, no more overlapping. Alright, no more overlapping. Okay, no more overlapping means that, okay, well done. Okay, good. Alright, okay, good. So, your next step, okay, determine your A, B, C by subting in your newly found YP into the original question of y p prime prime plus 5y p prime equal to 4x squared, and then you compare coefficients from both sides and solve. Okay? Go home. do. Okay? Okay. Alright? Okay, go back and solve for the ABC. Alright? But the main steps are shown to you already. Okay? Your next job is just to go and solve the ABC. Alright? In my here, alright, I have the solutions at the end. You go back and verify. Okay? Okay, check your solution. Please go back and try, right? Because this kind of question, if it come out in an exam, I will give 15 marks. Okay, 15 marks. Alright, at least 15 marks lah, 15 marks. Okay, so it's quite a good, right? And it's not difficult. Okay, it's quite manageable. Okay, cool. Next, we go and solve the next part 2, right? We go and solve part 2. Part 2 is here. Part 2 is here. Alright? Part 2 is here. Right? Okay, we have the questions here. Alright? Okay, because part 2 is very, very involved, right? That's why I already wrote it out. I wrote it out first, okay? So that I can focus on the explanation. Alright? So this is for our number 2, right? Y prime prime minus y equal to 3x ex, right? So the first step is that you solve for y prime prime minus y equal to 0, right? So your characteristic equation, right, will be r squared minus 1. Okay? You don't have r, right? Because there is no y prime, right? So it's r squared minus 1, set it to 0 and solve. You got r equal to plus minus 1. So your yc is just your c1e negative x plus c2e 1x. Okay? Alright? So you look at the right hand side. You look at the right hand side. The right hand side is 3x ex. Alright? So your first guess will be, what will your guess be? Your guess will be the ex copy down, right? 3x here, it will be ax plus b. You must have full polynomial, right? You must have full polynomial. Okay? You cannot just put, right? You cannot just put ax. Alright? You have to put ax plus b. Right? Ax plus b. Okay? Full polynomial. Right? Okay? Whatever is given in the question, you have to take him and his lower order. Right? Because they may still be embedded inside. You never know. Right? You never know. Okay? And I multiplied it out. Okay? I multiplied it out so that's easier for me to analyze. Okay? With the YC. Right? You see whether any overlap. So when I multiply it out, I got AXEX plus BEX. Okay? And then I compare my guess. Okay? I compare my guess with the YC. Unfortunately, right? This C2EX overlap with this BEX. Right? Overlap lah, This is a coefficient, right? This is a constant. This is a coefficient, a constant. Okay, it overlap in. Alright? Okay, don't tell me, this is B, this is C, Wow, I will. Okay, overlap. Alright, overlap. The idea is very simple because, okay, you see, this particular solution, this technique, is always a guess and check. It's not foolproof. Yeah, it's a guess and check. I mentioned this right in the first day already. It's a guess and check technique. Okay? So, if it overlap with here, it means that when you suck in this into there, this term will already be killed off already. It will output 0, 1. So when that happens, you're short of terms, You're short of terms here. Okay? You're short of terms here. Alright? Okay? That's why The remedy is that you have to modify it by multiplying an x throughout. So I multiply an x throughout, okay, and then I expand it out lah, I expand it out with ax squared ex, okay, plus bx ex. Alright? And then you see any more overlap? Now no more overlap with your YC. Now no more overlap with your YC. Okay, since there's no more overlap with your YC, you can start doing your business now to solve for the A and B coefficient. Alright, so what do? Very involved. Okay, very involved. I hope I did not make any careless mistake. I did this in the morning because this kind of thing you need very focused, very concentration, very high concentration level, right? So I did it in the morning. All right, I put it in there because later I do live later careless, you got to cancel, redo. Okay, so I write out carefully. All right, okay. Okay, so this is your YP, all right? This is the YP, the modified YP, all right? You have to find what is YP prime and YP prime prime, right? Because you need to sub this YP prime and YP prime prime back into the original differential equation, all right? So this one is just product rule, but I tell you, product is, although it's just product rule, okay, I spent about 30 minutes to do this question, okay, but maybe because I'm old, I'm old, okay, cannot, sometimes you all can do this much faster than me, because you're younger, your brain is more active, okay, so I do product rule, hopefully I didn't make any mistake, so you see this as two parts, right, then you product rule, okay, copy down one, differentiate one, differentiate the other one, copy down the other, copy down one, differentiate one. Okay, then you copy down one, differentiate the other one. Alright, then you YP prime prime, you do the same thing. Alright, do the same thing. Okay, can This is the original question, right? You sub in the YP prime prime and you sub in the YP. Wow, guys, this is clearly a case where I'm doing the question blindly without thinking. Do you notice something? Do you notice something stupid that I did? Do you notice something stupid I did? The question is YP prime prime minus YP equal to 3x EX. There's no YP prime. Oh, sorry. I still need to do YP prime. Because to get YP prime prime, you need to get YP prime first. Okay. So I was not stupid. Sorry. Okay. Yeah, because it's second derivative. So no matter what, to get the second derivative, YP prime prime, right, you need to get your YP prime first. Okay, so no running away. No running away. Okay, no running away. Okay, no running away. Okay, anyway, you sub it in. Okay, you sub it in. All right, equal to the right hand side. Okay, so right, you sub it in like this. Okay. Okay. You sub everything in until here, right? Equal to the right hand side, 3x EX. Okay, 3x EX. Now, the next technique, okay, is that over at the right hand side is XEX. Alright? I will start to compare the coefficient of XEX. Alright? So the right hand side is clear cut, is 3. Right? 3 times EX. So I put down 3 first. The left hand side, okay, you look out for whoever has the term XEX. Alright, you look out for whoever has the term XEX. Alright, okay, so I have already done it for you. It's the orange color, is the orange color one. Okay, that means this is potential, this is potential, and then this is potential. Alright, if you multiply them out. Okay, so I also copy down the coefficient. That's why I have this term here. Right, and then I solve. Okay, the B and the B cancel off. Right, so I got 4A equal to 3. Right, and then next I have other terms not used, which is x squared EX. Okay, which is x squared EX. Alright, so if you are using x squared EX, okay, you scan through the whole left hand side. Okay, for x squared EX, okay, you are left with A minus A, and the right hand side, okay, there's no x squared EX, so the coefficient is 0. Okay, so it's okay. A minus A equal to 0. Alright? Okay? And then now is, okay, what other terms not used? You compare coefficient of the pure EX term. Right? Okay, so you look at pure EX term. Right? You will get this B plus 2A plus B. And because right hand side has no terms with E power X, so the coefficient is 0. So you have this. Right, and then you solve. Okay, you solve. Alright, and because you have earlier on found that A is 3 over 4, you sub it in, right, and then you get your B is negative 3 over 4. Is everyone clear about this technique? It's very, very tedious. Okay. Alright. Okay, now if another way another way is this. Alright, another way is this. Okay, I'm doing the shortcut method. Another way is that if in the exam, or you a bit panicky, alright, you just multiply everything out, 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 multiply everything out. Okay, and then you set it to this side, and then you compare that directly. Okay, okay. But my way is systematically lah. Systematically, I try to compare. Okay, systematically. All right. Okay. So after that, you can now, after you have determined the A and B, you can sub the A and B back into the YP particular solution. All right. Okay. Okay, and this bring me to a small typo. All right, this one should be, okay, I'm very sorry, this one should be 4. Okay, based on our solving, right, we solved already. Okay, the A and B term. Okay, this one should be 4. Okay, sorry about this. All right. Okay, a small typo, which I saw it this morning. Very sorry. All right. Okay. All right. Okay. But your final general, okay, so when you sub in the A and B, okay, you got the Y particular solution. But please don't forget that ultimately, okay, the general solution that I want to see is YP plus yc. Alright, it's yp plus yc, is this part here. Okay, so you need to manually put in the y general solution, is your y particular solution, after solving for your a and b, right, or whatever, plus the complementary. Okay, plus the complementary. Okay? Okay, now let's go on to the last part, question number 3. Alright, question number 3. Okay, so this is the number 2. We managed to solve this already. So let's move to question number 3. Okay, here. Right, question number 3 is here. Okay, question number 3 is very ugly looking. Okay, it's here. Alright, okay. 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 Okay, first thing first, no need to worry, okay? You solve. Okay, you solve. The case of y prime prime minus 4y prime plus 5y equal to 0, which means that your CE is r squared minus 4r plus 5 equal to 0. Okay, so when you solve, r is equal to minus b plus minus square root b squared minus 4ac over 2a, what we did in secondary school, right? So we will have minus negative 4 plus minus b squared, which is 16 minus 4ac over 2. This will give me 4 plus minus square root. 16 minus 20 is what? 16 minus 20 is negative 4 over 2. And that will give me 4 plus minus square root. Square root of negative 4 is equal to square root 4 square root negative 1. So this is 2i. 2i. Right? 2i. So it's 2i over 2. This will give me 2 plus minus I. Okay? 2 plus minus 1i lah. Okay? 1i. Right? So therefore, okay, you can write yc x equal to c1 e2x cosine x plus c2 e2x sine x. Remember the summary table that I put in the slide for you? You can just use the answers directly. Okay, you can just use the answers directly. Okay, I need to see this form, right? You cannot give me the with the complex number. All right, for your YC, it has to be turned into the sine and cosine by Euler already. Okay, but no need to derive Euler and all that. Just remember the formula and use it directly. Okay. Right? You remember? You know what I'm talking about? Okay, let me just flash the last week lecture slides. Okay, I remember I give you a nice formula list. Give me a minute. Let me just pull it out. Yes. Okay. Here. Okay. Okay, sorry. Here. Okay? Right? This case is 2 plus minus 1i. Okay? You can use this complementary solution YC immediately. Alright? Use this answer. Okay? It's the same. Alright? After solving, you get these 3 possible cases. Then you can just write down the answer directly. Okay? Alright? And then let's continue. Okay, so given that your fx equal to 3e 2x sine x from the question, okay, what will you try? What will you try? What will you try? Okay, I will try e 2x for sure, right? And then inside here is sine x. When you see sine x, you cannot run away already. Right? You cannot run away. It will be a sine x plus b cosine x. Okay? Sine, if you see sine, you have to include sine and cosine. If you see cosine, you have to include sine and cosine. Alright? Okay? Because they are related one. Okay? There may be remnants of him around, the cosine and sine component. Okay? They may be included. Right? So you have to include both. Okay? Okay, now you compare the two boxes. You compare the two boxes. Are there any? Okay, so let me just write here. This is okay. This is full version. Okay, you have to consider full version. That's why I have a sine x plus b cosine x. Now, is there any overlap? What is the overlap? What is the overlap? Are there any overlap, and what is the overlap? Okay, good, right? The whole thing is overlapping, okay? The whole thing overlapping, right? Okay? Right? So, I just multiply a x throughout. Okay, I multiply a x throughout. Okay, then it stops the overlapping. Alright. This is too complicated already. Alright. Okay. So your next step, okay, your next step is to go and solve for the A and B. Okay, your next step is to go and solve for the A and B. Which brings me to ChatGPT. Alright? Okay? So we have done this part lah, huh? We've done this part together. Okay? We have done this part together. Alright? We have done this part together. Right? Okay? So the particular solution, right? The particular solution, did he get the same as us? X e 2x a sine x, correct, same. Okay, same. Right? Okay? Particular solution, and then he go and calculate the right, he go and calculate all this, whatever, right? Then he sub inside the differential equation, right? And then he compare the coefficient, right? Because left hand side must be equal to the right hand side. Alright, then he compare, okay, compare coefficient, right? He get A is negative 3 over 2, B is 0. Alright? Okay, so the particular solution is, okay, because one of the term give you 0, right? So the Y particular solution is this. Which I need to bring you back to our lecture slides. Again, my sincere apology. There's a minor typo here. Right? Okay? Okay, sorry about this, okay? Right? Okay, assuming ChatGPT is correct lah, it should be correct. I actually sub back to verify. Okay, one of the alphabet will be 0. Okay, that's why the particular solution is short of is just like that, very simple. All right, okay, and I hope you are not surprised because you see the original question the right hand side is actually sine. But the YP eventually give you cosine. It's like that. Right? Because you suck in first derivative, second derivative or whatever. They may cancel off, they may neutralize off, or redundant terms, etc. Right? Okay, so anything is possible. That's why we need to consider this. Okay, that's why we need to consider the full version. Right? The full version of involving both sine and cosine. Okay, you go back and try. Okay, you go back and try. Alright? You go back and try. Alright? So I already done like 90% for you. Okay? Until here, which I believe is the most important step until here. Okay? After this step is just standard procedure. You sub inside the original differential equation. After that, you compare the coefficient left hand side, right hand side, and then you solve for the unknown A and B, and then case closed. Alright? Okay? So ultimately, I need you to write the solution like this. Okay? Yx general solution is your Yc plus Yp. Then you take the Yc plus the Yp. Okay? This is the exact format that I want you to do. Okay? Happy? These three are the toughest already. Then plus your tutorial question, I think that is okay. That should be good enough. Alright, should be good enough. Okay? Alright? Okay, I promise you, alright, quiz 3, which is the last quiz, I will set a reasonable one. Okay? Actually, all my quiz are reasonable. All my quiz are reasonable. Alright? Okay, right? I didn't set to Q1. I set with... That means, okay, my philosophy is this. Alright? I do my best to teach. You do your best to learn. Okay? Right? If everything you have done, whatever I say, you come for the class, watch the video lecture, you do the tutorial, you go to the tutorial class, you listen to the solution, you clarify with the tutor, all these things you've done already, yet you still fail. Okay, this one I take responsibility. It's my fault. That means I teach lousy already. Wow, you do everything already, still cannot. That means it's definitely my teaching lousy. Okay, but if you do everything right, and then you still fail, wow, that means, wow, no, actually still your fault. Okay, still your fault. Okay, but I'm just saying that in the ideal world, it should be, okay, I set with the aim that such student should not fail. Okay, such student who go through all the things I just say, should not fail. If fail, it's really very sad. Very, very sad. Like, it's, okay. Yeah, I think this is, yeah, that should be the way. That's my philosophy. Okay, that's my philosophy. Okay. Okay, let's continue. Can Okay, I will upload everything by today, right? So that you can use for your revision. Alright, sorry about this, right? Minor typo, and then a minor typo here. Okay, let's continue. Some of different type. Okay, this is just a disclaimer page that the question can be made much more complicated. Alright, okay, but you don't have to worry, right? You already have all the technique and theory, right? So you can have this case. Okay, alright, f equal to 1 plus sine x, for example, right? So let's say you have f equal to f1 plus f2, where f1 and f2 are of different types. Okay, you find the corresponding yp1 and yp2 respectively. The trial solution for your yp will be your yp1x plus yp2x. Right? So there's nothing new. Okay? So basically, we separate each. Okay? Alright? And find the corresponding. So as I mentioned, your yp will be yp1 plus yp2. Okay? Nothing much lah, Nothing much. Okay? Okay? And then so we have one example here. Okay, good. We have one example here. So for this case, right, your yc will be c1e negative x plus c2 ex, right? Because you solve for your CE lah, you solve for your CE, right? And then your f1 will be 4ex. Okay, I just take one piece here, and that gives me my yp1 will be aex, right? Because your right hand side is 4EX. So I write AEX here, okay, as a gas. But AEX overlap with C2EX. So I need to top up with a X here. Okay, I need to top it up with an X there. And then next, my F2 will be equal to 5x squared. Okay, so my YP2 will be B2x squared plus B1x plus B0. Okay, the B0, B1 and B2 are just coefficient, right? I use these alphabets because to in line with the notes, right? So this part here is this part lah, right? And then this part here is this part here. It has to be a full polynomial. Okay, it has to be a full polynomial. Although here is only 5x squared, but we, as I mentioned many times, we have to do a full polynomial, right? Involving the lower terms as well. Okay? Alright? Okay. We are done, right? So next I will briefly mention about this another method called the variation of parameter method. Alright? Okay? Take note that this variation of parameter, alright, method will not be tested. Alright? This variation of parameter method will not be tested. Alright? But everything that we have been covering so far, everything is inside this. Okay, will be tested. Everything will be tested. This special method is very complicated. Right? I don't want to know this variation of parameter method is very difficult. So I do not test you, but I still mention. Alright? Only from this part, variation of parameter, okay, everything we are done so far still count. Okay, still inside the syllabus. Right? So the previous method suffer from some limitation. Right? The DE must be with constant coefficient. The FX is very special cases. Right? For example, it cannot be applied to such cases. Right? It cannot be applied to such cases where we have like this, right? Not in the table. Okay? So this is a very powerful method that can overcome the above limitation, but it's too complicated to implement already. Alright? You can just at least be aware lah. Be aware. Alright? So, okay, it's very powerful. You can have PX here, QX here, and FX. Right? Okay, so you have the case, the homogeneous DE, alright, and then you have whatever the solution, okay. Your particular solution, which is always the toughest to get, okay, is always the toughest to get. Now there is a concrete formula, okay, the formula is like that, okay. It's only one line, look very simple, but this part is complicated. Then you have to do integration. This part is also complicated and you have to do integration. Alright, so not worth it lah. Not worth it. Okay. This W term here is the Wronskian. Alright. Okay, the Wronskian formula is as follow. Y1, Y2 is like that. Y1, Y2, and then you do a Y1 prime and a Y2 prime. Okay, this will give you y1, y2 prime minus y1 prime y2. Okay, and this of course cannot be 0, right? If it's equal to 0, you cannot do already, right? Because you cannot have division by 0. Alright, okay, so you just cross multiply. Okay, y1 times y2 prime minus of y1 prime times y2. Okay. Okay, right? Okay, so there are some questions you can go back and try on your own. Alright, and this is the end of the entire chapter 3. Right, this is the end of the entire chapter 3. Alright? Okay? Can, so this is everything we have discovered so far. Alright? Okay? Yeah, we covered quite a bit today, Just go back and make sure you are familiar with the steps. Okay? For the quiz, it will be reasonable, right? Within the time frame of 25 minutes. Okay? That's what our typical quiz is. Okay? So maybe I just do a quick revision for these two questions, right? These two questions, slide 26. Right? Before I start, okay? Before I start the next chapter, right? I just go through quickly this slide number 26. Yeah, this one. Alright? Okay. So I think this is straightforward. I think this is the more this is the straightforward case. Right, then you solve. Right? Okay, part 2. Right, part 2, alright, your YC is like this. Alright? So your YP, right, because we look at here is 16E negative X. So our first guess is AE negative X. Alright? Okay? So previously I was trying to go through the situation with you that, if you forget to multiply by X, okay, you will see that when you solve, alright, you can't, okay, you see, you sub this Y particular solution in, you get 0. Right? You don't get back the right hand side. Right? And then that's why that was the first motivation, right, for you. And I told you that, okay, when you have this case overlapping, right, with your YC, this one, YC, okay, this one overlapping with the one term in the YC, right, you'll get problem. That's why we multiply X to the guess, to the first guess. Okay? And then from here, we can determine the A, which is what I did for you back then. Alright? Okay? So that pretty much conclude the entire chapter 3. Okay? That pretty much conclude the entire chapter 3. The time now is 1:30. So I will give you a short 5 minutes break. Alright? Then you come back, we start chapter 4. Okay? When you come back, we start chapter 4. Alright, 5 minutes break. Okay, I will set the alarm. Right, make sure you come back. Okay. Yeah. Yeah. Right, so this is the introduction to chapter 4 lah, huh? This is the introduction to chapter 4. Alright, okay. Okay, this is the introduction to chapter 4. So it's not too difficult, alright. It's still manageable, alright. I will highlight what I think will be more important now. Huh? Everything is important, but I'll highlight those that I think it will be more important. Okay, alright. Okay, so this is the right. These are the main topics lah. Huh? So today we are going to just mention vectors, parametric curve, right? These are all the introduction lah, huh? Motivation, right? These are all the notations, terminology. Okay. Then next week the video lecture will be the main dish. Will be like arc length, line integral, gradient, divergent, curl, all these things. Okay? Right? So I'm going to cover until here today. Okay, I'm going to cover until here today. Right? Okay. Scalar and vector. Right? So I think this need no explanation, right? All of you are engineering students, okay? You should be very familiar scalar and vector, right? So scalar is a quantity that is determined by magnitude, right? Vector is a quantity that has both magnitude and direction. Why I write quality now? Okay, basically it's just magnitude lah, huh? Then vector is both magnitude and direction. Alright? Okay, so vector is the one that we are more interested in, right? Velocity, displacement, magnetic field, surface tension, all this. Okay, these are vectors. Okay, so this one is like your max 1 really, right? Okay, or for those of you who are exempted max 1, these are what we typically learn in high school days. Alright? Okay, so let me just go through the notation. Alright? So in the exams, okay, I may bold the notation, bold the alphabets, okay, or I may write this way. Okay? Basically it's like that lah, huh? Okay? It's like that lah. Arrow. Alright? Okay? So they mean the same thing, right? Or I may write it this way. Okay, right? They all mean vectors lah, huh? They all mean vectors. Okay. Usually in the tutorial questions and the exam, I bold it lah. Okay, I bold it. Okay. So you see anything that is bold, it means vectors lah. Right? Okay. Because to type the arrow sign is a bit troublesome, so I bold it lah. Bold is okay. Textbook also use like that, right? Different textbook use different notation, but basically it's like that lah. Basically it's like that. All right. Okay. So in component form in 3D space, right? The bold A is he has 3 components in 3D space: A1, A2, A3. Right. So we can write it this way. We can write it this way, or we write it this way with the IJK. Okay, with the IJK. It means the same thing, right? Because this is also at the I. This is the J component. This is the K component. Alright? And then standard unit basis vectors. This is 1, 0, 0. I is defined as 1, 0, 0. J is defined as 0, 1, 0. K is defined as 0, 0, 1. Right? So these are the corner, right? The corner of the room, right? IJK, right? Okay, IJK, right? They are the most basic and fundamental. Everything is made up of these 3. Okay, everything to define everything in this room is something of I plus something of J plus something of K, right? To define it. Okay, that's why you have this case, right? Something of I, something of J, something of K. That's how we define the point in this room. Okay. Okay, these are very basic. Definitely you have seen this before, huh? Right, the length or magnitude, okay, we put the notation is the modulus of the vector A. And the formula is square root of the component A1 squared plus A2 squared plus A3 squared. Okay, you square each component, sum them up, take square root. Okay, direction, unit vector along A not equal to 0. Alright, so this is the definition of unit vector. Right? Okay, you take the vector, you divide by his length. Okay, take the vector, okay, you take the vector, divide by its length. Alright, that is the nicer looking. Okay, and then direction angles of vector A. Alright, so these are all should have done before lah, huh? Should have done before. Okay, right? Should have done before. Okay. Alright, so I'm just doing a quick revision. Okay, directional angles, alright, of vector A are the angles of alpha, beta, gamma, right, that meet with the positive x-axis, that the vector A meet with the positive xyz axis. Okay? Right? So these are the definition, right, of, okay, because your vector, right, your unit vector, your vector A, right, they can also be defined using the angle. Okay, that it make with the different XYZ axis. Right, these are usually, okay, all these are angles here and there and trigo, because these are usually for graphics lah. Computer graphics, okay, these are more for, you know, people doing graphics and things like that. Right? And then what is cosine squared alpha plus cosine squared beta plus cosine squared gamma? This one is obviously 1, right? Okay, obviously 1. Alright? Okay? Okay, because the magnitude of the unit vector u is always 1, right? Because it's a unit vector, right? So this guy, okay, this guy, right? His magnitude is always 1, right? Because it's a unit vector. Okay, when we write in this form, basically it means that it's a unit vector of length 1. Okay, this formula directly will make it become a unit vector, which means that we make him length 1. Alright, this is a standard technique that we do. Okay, don't worry so much. Okay, all these things, don't worry so much. It's a standard technique. Okay, I'm not going to teach Maths 1 all over again. Right, these are all the core of Maths 1. Okay, so but I'm just putting it here because you may need to use some of this formula, right, when we do more advanced things later. Okay, and this is equal to 1 because this is actually your u dot u lah. Basically is your u squared. Okay, so the unit length is 1 then you square it, so you get back 1. Okay, nothing much. Alright, I don't want to harp too much on this. And find the direction angle of the vector 1, 2, 3. Okay, of the vector 1, 2, 3. Right, so just use the same formula that I stated here. Right, just apply it. Alright, okay. So first you get the length of A, vector A is square root 14. Then you apply the formula, cosine alpha is whatever, cosine beta is whatever, cosine gamma is whatever, based on the formula from the previous page. Okay, I'm not going to derive it. Right, it has been derived before in your earlier years. Right, then your alpha, you just find the angle. Okay, I won't set this kind of question in the exam lah. Okay, I won't say, I'm just doing a revision. Right, okay. Because we are trying to build up on all these basic things. Okay, we are trying to build up on all these basic things, right? Because I need to use this kind of notation, right? Later I need to talk about making a vector become unit vector and things like that. That's why I'm doing this revision. Okay, next, dot or inner product. Okay, his name is called dot product, or sometimes people call it inner product of A and B. This is also a way, computer graphics people, alright, okay, they like to use this, okay, and also used for many other techniques lah, okay. Basically, it's a way to test out certain thing. Alright? Okay? So you can see, alright, this formula here, okay, is like this. I give you some numbers so that it's easier to see. So dot product 1, 2, 3 dot with 4, 5, 6. It gives you, okay, 1 times 4, 2 times 5, 3 times 6. So it's 1 times 4 plus 2 times 5 plus 3 times 6. Give you 4 plus 10 plus 18. Alright, that gives you 32. Right? Dot product. Okay? Alright? So dot product, there's also another formula. So A dot B, you can take the length of A multiplied by the length of B times cosine theta, where theta is the angle between A and B. That's why, right, when you have A dot B is positive, it means it's like this. Because of the angle. The angle cosine of the angle will determine positive or negative. Right? A dot B is 0. It's always because it's 90 degrees. And A dot B less than 0, it means obtuse, like this. Right? Okay? So A dot B, I mean just as a general thing. Okay? So A dot B, it could be based on whatever applications you are doing. Your A and vector A and vector B could be many other contexts in your engineering application. Okay, this one I leave it to your higher year module. But your A dot B, the higher number it is, it means that they are closer together. They are closer in direction. Okay, right? Okay, so if it's 0, that means it's 90 degrees. They have no relationship, right? And this is negative, means it's all the way. Right? Okay, that's also a measure of the two, how close they are. Right, so usually it's forces, forces, right? The simple example. Your forces, you dot already, you know that how close they are related, how close they are at an angle. Alright? If your number is high enough. Okay? Don't worry, I'm just giving you some physical intuition of all these things that you are doing. Alright? Okay? Okay? Alright? Perpendicular, or some texts use the term orthogonal, right? They mean the same, 90 degrees, right? Two non-zero vectors A and B are perpendicular or orthogonal to each other, right? We use that notation there. If A dot B equal to 0. Okay, for example, the standard basis vector ijk are mutually orthogonal. You dot them, they will give you 0. Right? I think it's clear cut, right? If I use, because that corner, you see the ijk at the corner, right? If you use 1 0 0 dot with 0 1 0, it give you 0 plus 0 plus 0 give you 0. Okay, so they are 90 degrees, right? Okay, are the vectors perpendicular to each other? You dot them, Okay, nothing much. All right, so you have this 2 2 negative 1, because ij came 2 2 negative 1 dot with 5 minus 4 2. 5 minus 4 2. This give me 10 minus 8 minus 2. Give me 0. Yes, they are perpendicular to each other because dot product gives you 0. Okay, applications of dot product. Okay, this is more important, all right? Because later on we are going to build on this theory to come up with a new formula. Okay, we are going to build on this theory to come up with a new formula, right? So this part here is important, right? Right, application of dot product. All right. Okay, the major application is to find work done by a force field. It concerns a body on which a constant force P, right, is a vector. That's why I bold it, acts on. Let the body move a displacement D, right, and then the work done by P in the displacement is computed as follow. Okay, the formula shown. When P and D are perpendicular to each other, the work done is 0. Okay, this one you will learn in high school already, right? Okay, if your force is this direction, right, your movement is, okay, that's, okay, is the work done will be 0. Right, work done will be 0. Okay. Okay. So, let's just draw a simple diagram. Let's say this direction, right? Okay. Your force is this direction, okay, acting on a passer. Okay. You have, okay, and then you move distance, you move displacement D. Alright, so this one you learn in your high school days, right? Okay, you find this angle, right? You have to resolve it first, right? Okay, you have to resolve it first. The P, okay, you take modulus, then you do a cosine alpha, right? Because I resolve it down. Okay, I resolve it down because the force in this direction, right? This is the force. You resolve here and resolve here. Here is no use one, right? Because the movement is here. So you resolve this way. So P cosine alpha, alright? Then you times the D. Then you times D. Alright? Okay? This one is modulus. Alright? And this formula, if you still remember what I have just gone through with you, okay, right, is actually the same writing as vector P dot with vector D. Right? Vector P dot with vector D. Alright? Okay? Right? That's why we have this formula over here. Okay, because you go back to dot product. Okay, you go back to dot product. Okay, dot product is here. Alright? Okay, so everything is consistent. Alright? Okay, so this is by definition. By definition. Okay. Cross product. Very, 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 very important. Very, very important. Cross product. Okay. Okay, I have to sit down. I think I'm getting old. Wow, my kneecap hurts. Okay. Okay. Okay, so sorry. Okay, so cross product. Okay, here is a product PRODUCT. Okay, cross product. Okay, cross product here. Okay, cross product. All right, cross product. Okay, of AB will produce a new vector C. All right, where C is very interesting. C will be perpendicular to A and perpendicular to B. Very interesting, right? This one you learned before, you learned before already, but it's very important, and I will revise again. All right, I will revise again. All right, okay, I will revise again. Okay, so as I mentioned, you A cross B, you will get a product C. Okay, a new vector C. C is perpendicular to A, perpendicular to B. And direction of vector C is given by the right hand rule. Okay, right hand rule. Right? You cross two vectors, okay, there will be a third one pointing up. Okay, so it's like this lah. It's here, it's here. Okay, you have this vector A, this vector B. After you cross, you will get a vector that is coming up. That's why it's 90 degree. Okay, 90 degree to vector A and 90 degree to vector B. Okay, so this is the formula, right? This is the formula for cross product. Alright, this is the formula for cross product. Okay, this one is have to memorize one lah. Okay, this one no shortcut. Okay, this one I have to memorize. Okay, but I can teach you a way to remember lah. I can teach you a way to remember. So you can do this. Okay, you can do this. 1, 2, 3, vector 1, 2, 3. You cross with 4, 5, 6 lah. Alright. So you do this. Okay. When you want to do for first row, right? You cover the first row. Okay, you cover the first row. You this one multiply this one minus of this one multiply this one. You cross. You zigzag. Okay, you understand? So you cover the first row. All right. You cover the first row. All right, and then you do a 2 times 6 minus of 3 times 5. Okay. Right? Then the same thing, you cover the second row. Alright, you cover the second row. You use 1 times 6 minus of 3 times 4. But second row is very, very tricky. Second row, you need to put a negative sign. You need to put a negative sign to the whole thing. Alright, this is the formula lah. It's a formula that, you know. Okay, so after you cover the second row, you do a 1 times 6 minus of 3 times 4. Okay, alright, but remember there's a negative sign covering the whole thing. Alright, and then the last row back to normal. The last row you cover the last row. Last row you cover the last row. 1 times 5 minus 2 times 4. Alright? Okay, you cover the last row. And then you do a 1 times 5 minus 2 times 4. Okay? And then this gives me 2 times 6 is what? 12. 12 minus 3 times 5 is 15. That means minus 3. Right? And then second row is 1 times 6 is 6 minus 3 times 4 is 12. So it's minus, it's minus 6. But there's a negative outside. There's a negative outside. So it's positive 6. Right? And the last one is 5 minus 8. 5 minus 8 is negative 3. Okay? Right? And if you don't believe, we do dot product. Okay? We do dot product. Okay? We try. This new vector C, right? This new vector C, right? Minus 3, 6, minus 3, dot with 1, 2, 3. We get minus 3 plus 12 minus 9. That gives me 0. Okay, that means it's really perpendicular. And the next vector is 4, 5, 6. So we use minus 3, 6, minus 3, dot with 4, 5, 6. That gives us minus 12 plus 30 minus 18. That gives us 0 again. So they are indeed, okay, this new vector C is indeed perpendicular to the original 1, 2, 3 and perpendicular to the original 4, 5, 6. Okay? right? So this is one method to do lah, right? But sorry, how come the thing fly? Okay, sorry, let me, yeah, okay, so if you're using this formula, yeah, let me, okay, this one I think is what they usually teach lah, huh? Okay, so you're using this formula. Okay, if you're using this formula, okay, we use back the example from just now, okay, your this one will be 1, 2, 3, 4, 5, 6, right? So your A2 is 2 times B3, 6 minus A3, 3 times B2, 5, right? This will be your I component plus A3, which is 3 times B1, 4, minus A1, which is 1, and B3 is 6. Okay, this formula, the way to remember is different from my one, right? But the final answer will of course be the same. Okay, this is J, and then plus the K is A1, B2, minus A2, B1. Okay, right, so let's multiply it out to make sure it's the same answer. This one will be 2 times 6 is 12. 12 minus 15 is what? Minus 3. Okay, plus 3 times 4 is 12 minus 6. Right, so it's 6J plus 5 minus 8, so it's minus 3K. Alright, same answer, right? Okay, same answer, right? Minus 3, 6 minus 3. Minus 3, 6 minus 3. Same answer. Okay, can? Right? Okay, my method is easier to remember lah. No need to follow formula. But okay, if you prefer, you can follow this formula. Then you just suck in the A1, A2, A3, B1, B2, B3. Okay, I'm going through this so carefully because I think it's important. Okay, okay, let's move on. Okay, let's move on. All right. Okay, let's move on. Properties and application. Okay, this one you can read on your own. All these are from these are all during high school days really. High school days vectors, right? And also maths 1, right? Okay. So A cross B is equal to negative B cross A. This one you can easily find out. The length of A cross B, right? Okay, that formula, if you are interested, you can go and Google. All right, I leave it to you. All right, okay. A parallel to B, your A cross B will be 0. Okay, this one I think I leave it to you. Okay, not difficult to see why. Right? And then, yeah, because they are parallel, right? So this is one way to detect lah. If they are parallel, you cross them, it's always 0 vector. Okay, I leave it to you to think through why is that so, right? Okay, this one is a shortcut formula, area of the parallelogram, right? So the derivation is like this, right? This is vector A, vector B, right? Okay, so this is angle theta. Okay, so cosine theta, you resolve it down. Okay, B sine theta, okay, you get this length, right? So you use this length, all right, use this length, multiply by the length of A, right? So length of A times length of B times sine theta, right? That actually give you back A cross B length, all right? Okay, I will include a video on NTU Learn on how this formula comes about. Okay, you can watch it if you are interested, right? Not so important, but if you are really curious, I will put a video there for you to watch. Okay, right? Find the area of the triangle with vertices as follow. Alright, so PQR lah, okay. Okay, there's a triangle PQR. Okay, PQR. So your first thing first, you definitely need to find the vector PQ and the vector PR. Okay, you need to find two vectors first lah, PQ and PR. Okay, next, right, you find a cross B vector. After you find an A cross B vector, you take the length. Okay, you take the length. When you take the length, you take square root every component squared, add up together. Okay, right? This is the length formula. This is the length formula. This is the length formula. All right. Okay, these are all high school, JC, your diploma days. Okay, so I don't want to spend too much time. For the area of the triangle, you take the answer, you divide by 2. Right? Because this formula give you parallelogram. Right? But now you are just half a parallelogram. You are triangle. You are finding triangle. Okay, you are finding triangle. So remember to divide by 2. Okay, remember to divide by 2. Alright, okay. I'm moving on. Scalar triple product. This is for finding volume already. Okay, this is up 1 dimension. Just now is flat. Now we are going to find volume. Okay, this one I leave it to you to read already. Okay, alright, this one I leave it to you to read. Okay, read on your own. Okay, scalar triple product. Alright. Okay, this one I leave it to you to read on your own. The solutions is all there. Alright. Okay, the volume formula, just follow. Alright. Okay, I don't want to mention too much. Okay. Here. Okay. Okay, I will continue on. Right. This part is very, very, very important. Alright. Parametric curve. Alright. Okay. Parametric curve, planar curve, and space curve. Right. From here onward is the main dish. Alright. Just now was all motivation. Okay. Motivation. Alright. But the cross product is important. Make sure you know how to do your cross product. Okay. Right. So yeah, let's start the proper one. Okay. Before I go in here, I just want to help you recall, right? The curve, right? In a plane, we have y equal to fx, right? And then we have x is x between a and b. We have this case, right? Okay, here is A, here is B. Okay, so this is what we call the explicit form. Okay, this is what we call the explicit form. Okay, this is what we call the explicit form. Alright? Okay, and then now, I want to mention the implicit form. Okay? Implicit form. So imagine I have this case. Sorry. Okay, imagine I have this case. Alright? So you have this. R equal to 1. Alright, then you have this t. Okay, this is a circle x squared plus y squared equal to 1. Alright. Okay, so this is the implicit form. Okay, implicit, what we call the implicit form. Number 3 is what we are interested in, is called the parametric form. Okay, parametric form. Alright, so you will always be in this form. It will be something like this: x equal to t, y equal to ft. Alright, where your t is between a and b. Alright, and then we have x equal to cosine t, y equal to sine t. Alright, and then the t will be between 0 to 2 pi. Alright, for the above example. Alright, this is for the above example. Alright, and this is the case where x squared plus y squared equal to 1. And then you will have cosine squared t plus sine squared t equal to 1. So it's satisfied. Okay, this is a very brief introduction. Okay, a very brief introduction, alright, of what all the different explicit form means, implicit form means, alright, and then parametric forms mean. Now, I want to ask you, okay, right, what is the purpose of doing parametric form? Okay, what is the purpose of doing parametric form? Why be so extra? Go and spend time and effort to do parametric form. What is the main purpose? It should be obvious, right? Okay, you see, the explicit form, there is the y equal to fx. And then the implicit form, you have like x squared plus y squared equal to 1, everything embedded. These are all not very friendly looking, not very useful, right? Not very friendly. But you see the power of parametric form? Instead of two variable x and y formula, you only need to have one variable t. Powerful or not? Right? The formula x and y embedded inside very confusing one. But once you parametric form it, okay, right, your only variable is t, right? T, you will control the x and y value. So powerful, right? Okay, but to parametric it requires some effort. All right, simple case, easy, straight away see. Like unit circle, straight away you see, right? X is cosine t, y is sine t, right? T between 0 to 2 pi, straight away, right? And to confirm that this is correct, you can sub back to x squared plus y squared, you get back 1. Alright? Okay? So, we will be spending some time to develop the idea for parametric form. Alright? So, these are some terminologies. Alright? Planar curve, right? That is the definition, that is the meaning. Okay? Space curve, right? Is a IJK. Alright? Take note of the notation here, right? And then RT is the position vector, where T is a parameter. Alright, so at different T value, you sub inside the formula, you will get different position. Okay, you will get different position. Alright? Okay, okay, sure. Okay, right? And then some other examples here. Right, some funny shapes. All right, okay. You have all these formula that dictate how the motion, how the position vector is, the movement. Right, and then parameterization. Okay, how to parameterize a curve. Right. Okay, If you don't mind, I will continue to finish up this part. Okay, Ken? If you don't mind, alright? Okay, now, how to parameterize a curve? Right? Find a parametric form of the curve, right? The function in explicit form given below, y equal to fx. Okay? So the first case, alright, we have this x squared plus y squared equal to 4. Right? So this case is just your x over 2 squared plus y over 2 squared give you 1. Because I divide by 4 throughout. Okay, here I always want, I want 1 here lah. So I divide by 4 throughout. Okay, and then to make it nicer, I put x over 2 squared plus y over 2 squared equal to 1. Right? And this is the case where, because I know that cosine squared t plus sine squared t equal to 1 as an example, right? Cosine squared plus sine squared equal to 1. So I can deliberately let this be x over 2 equal to cosine t. Therefore, x is equal to 2 cosine t. And then I have another case of y over 2 equal to sine t. Therefore, y is equal to 2 sine t. Okay, where my t is between 0 to 2 pi. Alright, so that I can transverse it fully. Okay, t is between 0 and 2 pi. Okay? Okay. Okay, next. Okay, next. We have the case of x squared over a squared plus y squared over b squared equal to 1. So it's similar lah, right? So it's x over a squared plus y over b squared equal to 1. So it's like your cosine squared t plus sine squared t equal to 1. Okay, so it's like your x over a equal to cosine t. So therefore, your x is a cosine t, right? Okay. Likewise, your y over b is like your sine t. So your y is equal to b sine t. Okay, where your t is between 0 and 1. Okay? Okay, I think I will stop here today. Right? I think I will stop here today. Alright? Yeah. Any questions? Any questions? I think I will stop here today. Okay? I think we did quite a lot of things today. Right? So I will stop here for today. Any questions? Okay, if no questions, I will end the class, right? Don't forget, coming Monday, tutorial class is your quiz number 3, the last quiz, right? The scope is the entire chapter 3. And then after that, Thursday is a public holiday, so I will upload the video lecture, right? You can have a good break lah, right? And happy Diwali to our friends who are celebrating. Okay, thank you so much. That's all for today. Yeah. Okay, that's all.